हॅलो, वेलकम, नमस्कार, आदाब, सत श्री अकाल. कशा आहात तुम्ही? मजेत ना? बघा मित्रांनो, आपण शिकत आहोत चॅप्टर मेटलर्जी. आणि ह्या चॅप्टरच्या आपल्या लास्ट लेक्चरला, कालच्या लेक्चरला आपण काय बघितलं? आपण बघितलं हाऊ वी एक्स्ट्रॅक्ट द मेटल्स, द एक्स्ट्रॅक्टिंग ऑफ मेटल फ्रॉम देअर रिस्पेक्टिव्ह ओअर and purification of the metal for the use. This is called as metallurgy. It is a branch of science and technology. Now, what are the process that is been takes place for extraction of metal? Ores are the mineral which contains maximum proportion of metal. Along with them some impurities are there, but ore are the substance, are the minerals from which metal can be extracted economically and profitably. It's called as ore. The steps regarding the extraction of metal was, the first one is concentration of ore. How to concentrate the ore? The removing of impurities from the ore is called as a concentration of the ore, and it is been takes place by the four methods. The first method was gravity separation method. In gravity separation method, two sub methods are there. Number one is a Wilflatable. Second one was hydraulic separation method. Then the second method, that was magnetic separation method. Above two methods means gravity separation methods are depends on the particle density of the metal ore. The density of the metal is more, and hence the metal particles can be easily separated, and the light particles of the impurity goes to the other. It can be separated in the another medium. Magnetic separation method is useful for those ore that are impurities are non-magnetic, means they are not attracted towards the magnet, while the metal ions, metal particles are attracted towards magnet, means they are magnetic in nature. For example, cassiterite ore can be concentrated by this method, in which Std.X is an impurity which is a non-magnetic, and it's collected the jar, the vessel which are kept afar. As the ferrous tungstate is the metallic ore that been attracted towards the magnet, and hence it is collected in a nearby vessel which kept below the rollers. So this is depend totally on the magnetic and non-magnetic particle behavior. Third one are the froth flotation method. In froth flotation method, the nature of the particles, that is hydrophilic and hydrophobic, is chosen. Hydrophilic impurities are weighted by water, while hydrophobic means water hitting ore, particles of ore are repelled by water, and they are collected on the foam, called froth flotation process. Then the last method that was we saw in the last lecture, that was leaching. In the leaching, the ore is soaked into the certain solution, and impurities are remain as it is. They does not dissolve in that solution, but our ore is react with that solution and get dissolved in that solution. So simply you can filter this ore after soaking for a particular duration, and you will got that in the your filtrate. The undissolved impurity remains as it is, and you can separate it by filtration. So that was the process. Now, for which compounds, for which ores these techniques are been using? So the gravity separation methods, that is Wilfley table, and the hydraulic separation methods are used for in which the metal particles are heavier one and gangue particles are lighter one. The second one was magnetic separation method, which is used for cassiterite ore. Froth flotation method is used for the zinc blend ZNS and copper pyrite, that is CuFeCS2, and leaching process is useful for bauxite ore. Now, in the last lecture, we also saw that the how concentration of bauxite is occur. So concentration of bauxite is occur by soaking the bauxite ore into the NaOH, sodium hydroxide solution, or Na2CO3, sodium carbonate solution. So this alumina get totally dissolved in the these solutions, and the impurities such as stannic oxide, titanium oxide, then ferric oxide, silica, these impurity are undissolved in that NaOH solution, and so we can filter it, and alumina got in the NaOH solution. Now in today's lecture we go in move further, and today we are recalling a question. Can you recall? Please see on page number 102 there is a question. Can you recall what is the electronic definition of oxidation and reduction? So regarding the definition of oxidation and reduction, we know that oxidation means addition of oxygen or removal of hydrogen. Oxidation is the process in which addition of oxygen is there or removal of hydrogen is there, and the reduction is the process in which addition of hydrogen is there or removal of oxygen is there. So these actually oxidation reduction process are exactly opposite to each other. In one process oxygen is added and hydrogen is removed, or and another process hydrogen is added or oxygen is removed, right? Regarding the electrons, now we are dealing with an electrons, how the definitions of oxidation and reductions are there. So let me give an definition. Oxidation means loss of electron. The reaction during which electrons are lost are called oxidation reaction. The reaction in which the electrons are lost are called oxidation reaction, and the reaction in which the gain of electron is there, electron gain is there, is called reduction reaction. What is called reduction reaction? So oxidation means loss of electron and reduction means gain of electron. Got it? These are the electronic definitions of oxidation and reduction. Loss of electron is called oxidation and gain of electron is called reduction, right? Then extraction of metal is the next point that we have to look out. Extraction of metal. You know that metallic series, the reactivity of metal series, we saw in the previous lectures. Some metals are highly reactive, while some metals are moderately reactive, and some metals are the least reactive. No, like sodium, potassium, aluminium. These elements are highly reactive metals, right? And the moderately reactive metals are also there, and least reactive metals are also there. So during the extraction of metal from their ores, metals are obtained from the cations of that metal. In this process, the metal cation is to be reduced. How to bring about the reduction depends upon the reactivity of metal. We can already learn about that reactivity series of the metal. So see friends, when a metal ore is taken to the extraction of metal, then metal cations are formed, and these metal cation we should or we have to reduce. So reduction is depend on which type of metal cation is there, and that type of reduction is done. And just now you remember just now I have told the definition regarding the electrons, that reduction means gain of electron. So cation having positive charge, it can gain electron, and it is stabilized. So metal can be reduced, metal cation can be reduced and obtain the metal. So this process is there. Now question arises that which metal ion is more reactive and which is not more reactive, which is less reactive. Means the metal cations which are more reactive or which are less reactive. So that point we already discussed in our previous lecture, reactivity of metal series, right? Now come towards and saw the point extraction of metals, and in that the first is extraction of highly reactive metal. बघा मित्रांनो, आतापर्यंत आपण बघितलं की मेटल एक्सट्रॅक्शनच्या प्रोसेस. आजच्या लेक्चरला आपण बघणार आहोत की एक्सट्रॅक्शन ऑफ मेटल. मेटलला जेव्हा त्याच्या ओर पासून एक्सट्रॅक्ट केलं जातं तेव्हा त्याचे कॅटायन्स तयार होतात. हे जे कॅटायन्स आहे त्याचं रिडक्शन करावं लागतं. मग आपण सुरुवात करूया लगेचच एक्सट्रॅक्शन ऑफ मेटल मध्ये. पहिलं एक्सट्रॅक्शन ऑफ हायली रिएक्टिव्ह मेटल्स. जसं की तुम्हाला माहिती आहे रिएक्टिव्हिटी सिरीज मध्ये मेटल्सच्या पोटॅशियम, सोडियम, ॲल्युमिनियम हे असे एलिमेंट्स, असे मेटल्स आहेत की जे जास्त रिएक्टिव्ह आहेत, जे जास्त रिएक्टिव्ह आहेत. मग ह्या रिएक्टिव्ह मेटलला आपण काय करायचं तर याचं एक्सट्रॅक्शन कसं केलं जातं ते बघा. प्लीज सी ऑन पेज 102 how it is been given. The metals of the top of the reactivity series are highly reactive. Their reactivity decreases down the series. For example, potassium, sodium, aluminium are reactive metals. Reactive metals have large capacity to form cations by losing electrons in their outermost shell. For example, reactive metals are react vigorously with a dilute acid given hydrogen gas. Highly reactive metal burn by reacting with oxygen from air at a room temperature. The extraction has to be done by electrolytic reduction. For example, the metals sodium, calcium and magnesium are obtained by electrolysis from their molten chlorides salt. In this process, metals magnesium is obtained by electrolysis of their molten chloride salt. In this process, metal is deposited at the cathode while chlorine gas is liberated at the anode. The electrode reactions during the electrolysis, molten sodium chloride is get metallic sodium as shown below. So metals on the top of the series are highly reactive metals. In that potassium, sodium and aluminium comes. These metals easily loses the electron which are present in the outermost shell of them, and they form cations. By losing the electron in outermost shell, they form positive charge on them and they are called as cations. Alright. So these metals are highly reactive and they react with a dilute hydrochloric acid to form hydrogen gas. These metals are also very reactive towards oxygen. They form their corresponding oxide and these metallic oxides are basic in nature, you know that. So basically these metals are very reactive, they are vigorously reactive. So how do we extract this metal? The extraction of this metal is done by the process of electrolytic reduction. Just I have told you earlier that cations should be reduced, or cations has to be reduced. So reduction process is there. Now actually what happened in this reduction process, when the salts of sodium, calcium, magnesium are formed, these salts are treated or taken for the electrolytic reduction. And there, you know that there are two electrodes are there, one is the cathode and another one is the anode. Cathode is a positively charged, see, electrodes. Cathode is positively charged and anode is negatively charged, right? So cathode is positively charged, anode is cathode is negatively charged and anode is positively charged, right? What? Cathode is negatively charged and anode is positively charged. So these electrodes, the solution is been taken, and when electricity start passing through it, what happens? The metal cation is deposited on cathode. Metal cation are deposited on cathode, and the chloride ions are deposited on the anode. Chloride ion are deposited on the anode. And how the reaction is been takes place, the electrode reaction is given below. Please see, on the cathode what reaction is been takes place? Sodium plus ion means it is cation, plus electron, it is converted into metallic sodium, and this reaction is called reduction, and this metallic sodium is deposited on the cathode, which is negatively charged, right? And the second one, anode, what happened? 2 chlorine gives away Cl2 plus 2 electron. So loss of electron is here, and this reaction is called as oxidation. Here gain of electron, so it is reduction, and it is in this reaction loss of electron is there, so it is called as an oxidation. Got it? बघा मित्रांनो, एक्सट्रॅक्शन ऑफ मेटल्स मध्ये हे जे हायली रिएक्टिव्ह मेटल आहेत ना, हे ऑक्सिजन सोबत रिएक्ट होतात, हे हायड्रोजन HCl हायड्रोक्लोरिक ऍसिड सोबत रिएक्ट होतात, आणि यांच्यापासून रिस्पेक्टिव्हली मेटल ऑक्साइड्स तयार होतात ऑक्सिजन सोबत रिएक्ट झाल्यानंतर रूम टेम्परेचरला, आणि हायड्रोजन गॅस लिबरेट होतो जेव्हा हे रिएक्ट होतात HCl हायड्रोक्लोरिक ऍसिड सोबत. ह्या मेटलचं एक्सट्रॅक्शन करण्यासाठी काय केलं जातं तर इलेक्ट्रोलिटिक रिडक्शन मेथड लक्षात घ्या, इलेक्ट्रोलिटिक रिडक्शन ही मेथड वापरली जाते. या मेथड मध्ये काय केलं जातं तर जे सॉल्ट्स आहे म्हणजे सोडियम, कॅल्शियम, मॅग्नेशियम यांचे जे क्लोराइड सॉल्ट आहे, जसं सोडियम क्लोराइड, कॅल्शियम क्लोराइड, मॅग्नेशियम क्लोराइड, यांना काय केलं जातं, यांना इलेक्ट्रोलिसिस प्रोसेस साठी घेतलं जातं, आणि यांचे मोल्टन क्लोराइड सॉल्ट्सचं काय केलं जातं, इलेक्ट्रोलिसिस केलं जातं. मग याद्वारे यांचे जे आयन्स आहेत ते सेपरेट केले जातात. जसं मेटल्स कॅटायन्स असतात, मग या कॅटायनचं रिडक्शन केलं जातं. मेटल कॅटायनचं रिडक्शन झाल्यानंतर हे कॅथोड वरती रिएक्शन घडून येते, कॅथोड वरती रिडक्शन रिएक्शन घडून येते, जिथे इलेक्ट्रॉन दिले जातात म्हणजे घेतले जातात मेटल कॅटायन कडून, आणि मेटल जो डिपॉझिट होतो तो कुठे होतो, कॅथोड वरती होतो. So at the cathode what reaction takes place? Sodium ion which is cation gain an electron. हा इलेक्ट्रॉन घेतो कोण, सोडियम, आणि त्याचं काय तयार होतो, मेटॅलिक सोडियम है ना. आणि हा मेटॅलिक सोडियम जो आहे हा कॅथोड वरती डिपॉझिट होतो. आता हा जो मेटॅलिक सोडियम आहे हा कोणत्या रिएक्शनने तयार झाला, रिडक्शन. थोडक्यात काय, कॅथोड वरती रिडक्शन रिएक्शन झाली, सोडियम आयनने, सोडियम कॅटायनने एक इलेक्ट्रॉन घेतला आणि त्याच्यापासून मेटॅलिक सोडियम तयार झाला. तर दुसरीकडे एनोड वरती कोणती रिएक्शन झाली, एनोड वरती हे जे दोन क्लोरीन ऍटम होते यांनी इलेक्ट्रॉन दिले. प्लीज सी 2Cl gives Cl2 क्लोरीन मॉलिक्यूल तयार झाला आणि याने 2 इलेक्ट्रॉन दिले. सो इलेक्ट्रॉन लॉस इज देअर अँड दिस रिएक्शन इज कॉल्ड ऑक्सिडेशन. जिथं इलेक्ट्रॉन घेतले जातात ती रिडक्शन रिएक्शन असते आणि जिथं इलेक्ट्रॉन दिले जातात ती ऑक्सिडेशन रिएक्शन असते इन टर्म्स ऑफ इलेक्ट्रॉन्स, इलेक्ट्रॉनच्या संदर्भामध्ये. मग कॅथोड वरती इलेक्ट्रॉन घेतले जातात म्हणून इथं रिडक्शन म्हटलेलं आहे, तर एनोड वरती इलेक्ट्रॉन दिले जातात त्या ऍटम कडून म्हणून त्याला रिडक्शन म्हटलेलं आहे. कॅथोड वरती मेटल डिपॉझिट होतो कारण कॅथोड हा निगेटिव्हली चार्ज इलेक्ट्रोड आहे आणि metals are positive, you know that. So there is always attraction between positive and negative charges. So cathode is being negatively charged, it is attracted towards the metal. And anode, which is having a positive charge. So on this anode, the negatively charged element like chlorine, you know that Cl minus ion is there. So this is deposited on the anode. In this, chlorine loses the electron, so the reaction is called as oxidation reaction. मग याच्या पुढचा जो भाग आहे तो आपण बघूयात. एक्सट्रॅक्शन ऑफ ॲल्युमिनियम हा जो पुढचा पार्ट आहे तो आपण सुरू करणार आहे, पण कधी? पुढच्या लेक्चरला. तोपर्यंत घरातच राहा, सुरक्षित राहा आणि शिकत राहा. शिकणं थांबवू नका. धन्यवाद.